Today I will show how to create private logical nodes using SCLManager. In this project, I have a sample IED with logical node 0. If you browse and try to add logical nodes, all standard logical nodes can be added using this option. But if you are not able to meet the requirement using standard logical node to represent your IED, then you may go ahead with private logical nodes option. In this case, there are no private logical nodes added. SCLManager is not installed with private logical nodes. User is expected to add private logical node based on different use cases. For that, browse to Tools menu and access Private Manage Data option. There are different options like adding a logical node class, data class, data attribute, and enumeration. Any of these elements can be added and used under edition 1 or edition 2. The added private logical node will be available only under the respective project type and edition. So make sure that the respective project type is selected before adding the elements. As a simple example, I will create a logical node, say my ln, and browse any logical node which is very similar to what I need. For example, GGIO. So this is one way of adding a private logical node. If a logical node meets most of your requirement, you may simply rename or edit the elements in those logical nodes to meet your requirement. So to indicate that it is an inherited logical node, I will give the name IN, which means inherited. You could give any name for your case. You may use the logical node or inherited logical node as is, or you may change some of these elements to meet the requirement. For example, here I have changed the name to analog or digital. So this is the simplest use case you can think of. And you may remove the unwanted logical nodes. Or retain other logical nodes if you are interested in them. So in this example, I have created a logical node with analog value. If one is appended, that means multiple instances of the respective data object can be instantiated while creating the logical node. If you want to mark it as fixed, that means if no data objects need to be instantiated, then you may remove one appended to the data object name. So we have analog, which can be instantiated with multiple instances, digital, alarm, and warning. So I'm saving this logical node for my future use. Now let us see how common data class is added. Same process could be followed. So I will inherit a common data class. So for example purpose, I will use I will use complex measured value as a base class, and based on the need I could change the names and use as per the specific use case. To make things simpler, I will remove other elements which are optional. So it's also possible to create a common data class or a logical node without inheriting from existing available data types. If you are not interested in substitution and other 61850 functions, you may leave those elements blank. And you may create any element if you feel appropriate. So I have created a sample common data class which I can use for future. Same process can be followed for a data attribute. So in this case, I had inherited it from complex measured value. So to match the case, I will use a vector. So in this case, I have just inherited the data attribute from an existing data attribute vector and change the names to suit the use case. Same can be applied to enumeration. If you feel that existing standard enumeration doesn't meet your use case, you may pick an appropriate value to meet the use cases. So in this example, I have created a enumeration with 4 values. And now you may use this created enumeration in new data objects. And at this point, you may reuse your already created private attributes and further extend So in this case, I'm going to use the enumeration which I have created just now. So using this process, you may extend your data classes and attributes to any level either by using existing logical nodes or data classes or data attributes, or by creating newer ones. I'll show you how to create a simple common data class. You may reuse already created data class if that matches your requirement, or you may make it a complex data class by reusing already created data classes. For example, in this use case, I can show you how to create a complex data class using already created data classes. So I've picked up a sample use case where we need to represent upper, normal, and lower data points which are complex of a system. So once added, we need to create the preconditions or assign the preconditions so that this can be used later. And using these complex types, we could create more number of LNs. So it's possible to either use inherited information or create newer ones. So this was the logical node we created earlier. But if it makes sense to extend that further, it's possible. So this is how you could create different type of logical nodes. So in this use case, we have created my LN, which was inherited from GGIO. We also created my inherited common data class, and it was inherited from CMV, which is composite measured value, complex measured value. And we also created two data attributes, and we also created an enumeration and reused that enumeration in a data attribute creation process with state. We also created a complex data class using already created data classes. So any combinations can be used to extend existing logical nodes to customized logical nodes. So let us add these logical nodes into our sample project and see the behavior. Now if I browse to private logical nodes, I can add any of the newly created logical nodes and with any number of instances. The behavior of this logical node will be exactly same as other standard logical nodes. So you could see the analog value which were added. Digital values could create multiple instances of these analog values, and digital values as per the need. You may also create the other logical node which we created. And let us expand and find that elements which we have added. But as you can see here, looks like I missed to set the data classes appropriately. So this could be a mistake which you also may do. So while selecting the data objects, we need to select the CDC appropriately, so that then only it will populate the correct elements. So we missed to select this part, so it is still displaying the measured value and complex measured value in the newly created private logical nodes. So let us update these elements so that it's appropriately created. So in the first example where we inherited the logical node, we have inherited from existing data classes. But in the other case, we have created an entirely new common data class. So let us verify that here. So you could see that all the newly added elements are available. You could see that these elements were added newly, and the names and other information are created based on the specification. If you are not able to see any element, make sure that the appropriate data classes and data attribute selections are made. So in this example, you could see that the upper is using my IC, which is the type. So if you select appropriate data attributes and data classes, you will be able to get the right information here. So my DA was not used in any of the representations. We could create a and in this example we could add any of the details here. So like structured value, we could select the structured value and select any of those elements. We also need to ensure that preconditions are set appropriately. I'm just trying to show how to add the elements. And in your future data classes, the XYZ can be added. If you encounter these errors, make sure that you correct them and proceed. So in this case, I have set the lowercase as the first alphabet. It is expecting a uppercase. And now we have updated my ln. If you want to add any additional elements, that is possible. So new XYZ is already added here. So in this fashion, you may extend the IED data models as per your requirement. You may assign any name to any of these elements and proceed with the data model creation. Thank you.